Good afternoon, folks. Good to welcome you here in the afternoon. We generally have our programs, not all the time, but generally in the evening, early evening. And this, as you know, is a two-part program. First part, the science of obesity, and the second part, the politics, really, of obesity. And I am Alan Schriesheim. I'm the president of the Chicago Council on Science and Technology and the former director of Argonne National Laboratory. I'm pleased that we are partnering, Council on Science and Technology, C2ST, is partnering with the Harris School, Center for Human Potential and Public Policy at the University of Chicago. The Chicago Council on Science and Technology is dedicated to raising the awareness of the importance of science and technology in our society. I recommend that you pick up information on the organization that is new in Chicago and join. The partner organization, the Harris School Center for Human Potential, is a research training center and obviously located within the Harris School of Public Policy at the University of Chicago. And their goal is the understanding of human conditions from pre-birth to old age, identifying public policies, technologies that support achievement, health, and well-being across this spectrum. Delighted to have these two organizations co-sponsor what is an important issue in our society today, obesity. And I'd like to introduce Mary Hendricks, who will serve as the moderator, the further introducer of our speakers, and the moderator, Dr. Hendricks, Mary to her friends, and I know one another for a long time. Mary is the president and scientific director of Children's Memorial Research Center at Northwestern University's, School of Medicine. I am on the board of Children's Memorial Hospital, have been on that delightful board for a number of years, and that's how I got to know Mary. Mary is a very, very well-known researcher, scientific administrator, over 200 publications in biomedical research, recipient of the prestigious Merit Award from the National Cancer Institute, a holder of several patents, and I'm not going to read through her bio. She's a member of a number of important and prestigious boards, asked to give talks throughout the United States. And as we say in the profession, Mary is a legitimate member of the profession. So, Mary.
Thank you so much, Alan. I appreciate it. Thank you. Well, thank you. Well, I'd like to add my welcome to everyone who joined us today. I'd like to really thank in advance our panel of expert speakers. I think you're really going to be excited about today's program. Now, before I introduce our first speaker, please allow me to introduce a very distinguished member of our audience, Dr. Louis Landsberg, who joined us today. He's Dean Emeritus of the Feinberg School of Medicine and Director of Northwestern University's Comprehensive Obesity Center. So when you have an opportunity to interact with Dr. Landsberg, I think there are many collaborative partnerships that could be developed. And just to point out that early in the 1980s, Dr. Landsberg, with his collaborator, Dr. Young, discovered that insulin could stimulate the sympathetic nervous system. And this was a very important cause of obesity-related hypertension. And today, you're going to learn a lot more about these complex interactions of diet, of exercise, of hypertension, cardiac-related malfunctions. And so, without further ado, I'd like to introduce our first speaker today. Just some housekeeping rules. Each speaker will have 20 minutes for their presentation. We ask you, the audience, to remember your questions and then ask them at the end during our panel discussion. So Dr. Hankinson is our first speaker. She is a cardiovascular epidemiologist with a special interest in obesity. She completed her medical degree and residency in preventive medicine and master's in epidemiology from the University of Maryland. After serving in the United States Navy as a preventive medical officer, she came to Northwestern University as a fellow in cardiovascular epidemiology and prevention. She has authored many articles on the roles of activity and fitness in weight gain and cardiovascular health, and is the course director for the Obesity Epidemiology course in the Program for Public Health. Her current research focuses on cardiovascular health determinants with respect to the obese, including the impact of obesity duration on cardiovascular disease and health and the quality of life. So Dr. Hankinson, we await your presentation. Thank you.
Good afternoon. And I hate to disappoint some of you all, but I won't be talking about most of the things that she said I am interested in, so sorry. You can ask me later. Okay. I wanted to give you all just a general overview of obesity from an epidemiologic perspective. And so the three main things I'm going to focus on are just providing a working definition of obesity, talking about prevalence trends in obesity, and this is going to be US-centered, so we're not going to talk about the global obesity epidemic. And then last, I'm going to talk about some determinants, both at the individual and the community level. So you'll notice that I'm not going to be talking about the associations of obesity with health outcomes, and maybe I'll say just a couple of things about that in the program, but not too much. So if you have questions about that, also ask me later. Okay. All right, so I want to first put up this pretty provocative slide because most of us have an idea in our head of what we think obesity is. And so I figured this is a slide that addresses what most people automatically think of when they think of obesity, and it's extreme. But this is the, the working visual we have of obesity, and it may not fit what the actual definition of obesity is. So let's try to figure out what that might be. Now, there's lots of disagreement about many things related to obesity, and it comes down to disagreements even at the basic level of what the definition is. And so I put up here three different definitions of obesity, and they vary in terms of whether they think fat alone or fat in terms of weight in proportion to height, or just accumulating fat is the important part. Also, some definitions say that we have to consider health impacts when we define obesity, but not all. So there's been a lot of hassle about how to define obesity, and it's only been in the last 15 years, since 1997, that we've had a pretty consistent definition of obesity, defined as excess body fat or body weight expressed as body mass index. Now, this is not a new concept. It's a concept that dates back into the 1800s, but its application in terms of looking at how it estimates body fat is what's new. And in the last 15 years, what we've said is that BMI, which is measured as weight over the square of height, and if you are not into the metric system, I provided it here in pounds and inches, and someone with a calculator might want to tabulate their own BMI. But we use a threshold of 30 to define obese. Now here's a range, and BMI is a measure that's a continuous measure. So, there are lots of points in between this 30 threshold. And what I put here are sort of green to yellow to red to indicate what people perceive, not what people perceive, what we generally consider to be your increased risk for health outcomes. Now, the threshold of 30 is related to the risk of death. And so at BMIs of 30 or greater, we generally acknowledge that your risk of dying goes up quite dramatically. But even at BMIs in what we call the overweight range, we see that your risk of death does slightly increase, but it's actually pretty low. So you really only get an increased risk of death at BMIs of 30 or greater. Now, you see that it's red here at the underweight range, and that's because it's not that having a low BMI is so great, because people who are underweight also have an increased risk of death. And what we generally say is that there's a J-shaped relationship between BMI and your risk of dying. Now, again with a visual, here's a chance for you all to now knowing that BMI of 30 is obese, where would you put the person who has healthy weight versus overweight versus obese? There's the healthy weight person. This person's overweight. And it's actually, you'd be a little smaller than this person to be considered obese. And that might be surprising, especially for clinicians in the audience who, have patients come in to see them very often, and who triggers in your mind someone who needs special counseling for obesity. Is it someone who looks like the person who's overweight? Is it someone who looks like this person? Or are you doing it when you see people who only look like they're at the extremes? Now that we have a definition of obesity and we know what it is based on BMI, and we know how you should look theoretically with a BMI of 30, we're moving on to prevalence. Now, when we talk about prevalence in the United States, there's two good sources for prevalence data. One is a measured height and weight that's done throughout the nation. And I put this picture of the trailers up here because basically the Centers for Disease Control sponsors a National Health and Nutrition Examination Survey. It's done continuously now. And all these people are here because they are asking you questions and they're measuring things, including height and weight. But also, there is a survey that's done by telephone. It's done by state health departments, and I don't know if any of you have ever been called, but they call households at random and ask them to give them their height and weight. And the two different methods are both very good sources of data. We just have to understand that when you're asking someone a question over the phone, they may misrepresent their information. they may not know their current information, and so the telephone derived information may be less accurate. So here are the trends in obesity over time according to NHANES, which is the survey where height and weight were measured directly. And from 1960 to 1962, when we first have measures of this in adults, we see that the prevalence of obesity is 15%. And then I also have BMI greater than or equal to 40, which is what people consider, they call it extreme obesity, but it's class 2 or greater obesity, class 3 obesity or greater. And it's very low, less than 1%. But after 1980, we see that the rate of obesity in adults increased quite dramatically. And this is basically a doubling of the prevalence since 1980, where we have now, our most recent estimates give us a prevalence of 34% for adults. The prevalence of obesity in children similarly has increased. And we know that in kids, it's a little more difficult to come up with a definition of obesity because we expect kids to grow, meaning that we expect them to gain weight. However, we use a threshold of being at the 95th percentile or greater for height, for weight with respect to height. And using this definition, the prevalence of obesity in kids has risen from about 5% to 17%, which is a threefold increase in risk. So we have a doubling of risk in adults, a threefold increase of risk in kids, and we note that the prevalence of class 3 or extreme obesity has similarly increased at an extremely high rate, and this is 6%, so going from a little less than 1% to 6% is about a six-fold increase in risk. We get similar numbers when we look at the data from people answering to telephone surveys, and many people remember these graphs. They show the US continental and Alaska and Hawaii starting in 1990, and now to 2010, we've gone to most states having between 10 to 15% obesity to having 12 states with obesity prevalence rates of 30% or more. Okay, so this is something I want you all to keep in mind because we're about to move on to determinants of obesity. Obesity is complex. It's not a simple thing. It has many factors influencing it. And I'm not going to call obesity a disease. I'm going to call it a phenotype. It is a clinical appearance that is generally due to the joint actions of both the environment and our genetic makeup. Now, obesity varies by several things that we know, and unfortunately, many of them we can't change. The top three are gender, age, and race. And so I just wanted to show you that you see that at all age groups, obesity prevalence is higher in women than in men. But obesity also increases in general as we get old. Also, obesity differs according to our race versus our race or ethnicity, and because we're using NHANES data here, we can only look at whites, blacks, and Hispanics. But there is other data to support the fact that Asians have the lowest prevalence of obesity, and that Native Americans probably have an obesity prevalence somewhere in between whites and Hispanics. Now, the prevalence of obesity, as I said, is around 33%, 34% for all US adults, but it does vary by race, and I've put a 50 with the circle around it because the obesity rate in Black women is 50%. I think this is something that you all should take special note of because we say 1 in every 3 people is obese. It depends. And if 1 in every 2 Black women is obese, this is a group that deserves special attention. So I said that both genes and the environment are responsible for obesity, but I want to make sure you all understand that the increase in obesity prevalence in the last 30 years is not likely to be due to genetics. Now, we know that BMI is something that is inherited, and we think that the rate of inheritance for BMI is between 25 and 40%. And we also know that obesity clusters in families, so that if you have a mother, father, brother, or sister who is obese, your odds of being obese are double than that of anyone else in the general population. So we know genes play a role, but whether it's one gene or multiple genes is what people get confused with, and I want to make sure you know that it's usually multiple genes. Now, there are some genes that are responsible with a single mutation for causing obesity. Leptin is one, and many of you might have seen the mice, and one has the leptin gene mutated and the other doesn't, and the mutated leptin gene mouse is very large, whereas the normal mouse is a normal size. In US adults, most likely, they don't have leptin deficiency. They most likely have multiple genes that interact with each other and interact with the environment, causing obesity. Now, there are things that we have more control over than our genes, our gender, our age, and our race that determine obesity. Social and cultural factors are more changeable, but they are also subject to both our individual behaviors and things that at the community level that are less changeable. We know that obesity is affecting men, women, children, adults, and it doesn't matter your economic strata, everyone is impacted by obesity. But in general, people of lower socioeconomic status have higher rates of obesity than people in higher socioeconomic status. And there are many reasons we think this is the case. We think it could be access, people who have more access to healthy fresh fruits and vegetables, who have more access to recreational facilities and parks, will have lower obesity because they can engage in healthy behaviors. It could be true also that people have differing opinions of whether obesity is a bad thing or not. We noted that Black women have the highest prevalence of obesity, but it's also known that Black women have the lowest body dissatisfaction, and that means that at a higher BMI, they're pretty satisfied with their appearance. They don't associate obesity with some of the negative connotations to the extent that white or, well, mostly white women are associating obesity with. And that is a cultural factor that may account for higher obesity rates in that particular subgroup. Now, even though the socioeconomic influence on obesity is inverse, that's an association that's only seen in whites. And we can't explain why the socioeconomic relationship between obesity isn't the same in all ethnic groups, because in general, behaviors are the same, even though some cultural factors may be different. I want to make sure you see this graph where we can compare how prevalence of obesity by socioeconomic status has changed from 1970s to 2000. And both in men and women, you see that low SES, as I said, is associated with higher obesity rates. But we see that this gap is narrowing, particularly in women. And this data only goes out to 2000, but we expect that in more recent years, we would see a convergence and maybe even a crossing over where high socioeconomic, or convergence where high socioeconomic status is less protective of obesity for reasons that may point to larger community obesogenic environmental sources that aren't so individually driven. So this is a slide that lets us know that obesity is definitely inversely associated with socioeconomic status, but that's changing because our culture is changing to the extent that having higher income and higher education isn't protecting us from unhealthy behaviors. Now, where we live is something that's a slightly changeable thing, and the states that have the highest obesity rates are southern states and states in the Midwest. But the states in the West and in the Northeast aren't very far behind. And so people generally say that the South is the stroke belt because it has a higher obesity rate, and you assume that these people are perhaps engaging in unhealthy behaviors. But really, we're seeing that the US is becoming more homogenized in terms of our risks, our exposures, and our behaviors. Now, one of the main risks that is generally thought to be individual, but also has larger community determinants, is nutrition. And in general, people are consuming a Western diet today which is energy dense and nutrient poor. It has generally high salt, high sugar, and high fat content, usually from animal sources. People are also increasing their snacking behavior, meals, eating between meals. They're eating more meals outside of the home, and they're eating meals with larger portion sizes. And these things are actually very related because portion sizes are a way for a restaurant to increase their profit margin. And so the more we eat outside the home, the more we're eating larger portion sizes, which reorients our expectations to what a portion is. Now, on the low end of the scale, we're not eating foods high in fiber. We're not eating foods like fresh vegetables and fruits and whole grains. And so we have a lot of the bad, not a lot of the good. And many people would expect this to be behavior-driven. We should make more healthy choices and less unhealthy choices. But I'll present a little bit of data which will let you know that this isn't so subject to individual decisions as we think. Also, the level of physical activity is definitely changing, both occupational and transportation, which most people don't measure, and leisure time, which many people think accounts for most of the relationship between activity and obesity. But I put occupational first because for those who work 8 or more hours a day, that's where you spend the bulk of your time. And not only do we have a change in technology and our economy being shifted to the hospitality sector, the information sector, so that we have less jobs available where you need high levels of physical activity. When we are in our low activity jobs, we require less activity to do those jobs. So instead of walking to a colleague's office, we send an email. Instead of taking the stairs up the 4 flights to our office building, we take the elevator, and et cetera. So we require less activity for everything that we do, particularly in the portion of the day that we spend the majority of our time. This is also true of transportation. We take cars as opposed to walking or biking, and in cold weather areas like the Midwest, there are entire chunks of the year where it's not very comfortable to walk or bike. But whether we choose to take public transit versus taking a car is something that may seem like an individual choice, but also has larger community components to it. I'm not going to talk about leisure time activity because it's the thing that we find to be most changeable. However, it has very little influence on our overall activity level. And this is just a slide that shows that many people have a daily activity log that might be similar to this. You might get 30 minutes of activity a day, but you spend most of your time sitting, either in your commute, your time at work, your time away from work, watching TV, on the internet, etc., and eating, and then you sleep for 8 hours. So in general, you spend 97% of your time either sleeping, sitting, or doing very light activity. And it's only this 3% that is any purposeful exercise. And so the expectation that that 3% might have some huge influence on your BMI is somewhat misguided. Unfortunately, however, this is the part that's easiest to recall and easiest to measure, and that's why it's gotten the most focus. So I've tried to say all along that for every determinant of obesity, there are individual components and then there are larger community factors at work that we have little to any influence on. Neighborhood characteristics is something that's gotten a lot of attention recently, and so think of your own neighborhood and your access to healthy food choices, your access to recreational facilities or parks, your level of safety and how comfortable you feel either biking through your neighborhood or taking a walk after dinner. And the level of racial segregation in your neighborhood, sometimes that's protective, sometimes it's not. But the fact that it's there may have a huge influence on your access to choices. And many people have seen or heard of a study done by Mari Gallagher in Chicago in conjunction with the LaSalle Bank on food deserts, which are, as a definition, areas with no or distant grocery stores. And what this study did very well was take the city by neighborhoods and look at a variety of factors. One of the things that they did very well was they measured the distance to the closest grocery store and then measured the distance to the closest fast food restaurant and created what they call a food balance score. Having a low score is good because that means that the distance to the closest grocery store is small and the distance to the closest fast food restaurant would be large. So low food balance score is good. And what we note is that in the neighborhoods with the highest BMI, they're the ones in red, most of them had the worst food balance score. Now, some neighborhoods with average BMI had bad food balance scores, but in general, those neighborhoods with the highest BMI had the worst food balance, and those with the lowest BMI had the best food balance scores. And so depending on where you live, many of your choices may be predetermined. And so I believe my 15 minutes are up, but I'd like to leave you with the basic message that obesity is highly prevalent. 30% or more of US adults are now obese. It has determinants that are modifiable when it comes down to behaviors, but many of our behaviors are much less subject to change than we think, and the impact of gender, age, race, and genetics are always overlain on top of all of those and cannot be changed at all. Thank you.
Well, thank you very, very much. What a great way to start this afternoon's discussion. I'd now like to introduce Dr. Burton Freeman. She's been involved in obesity and metabolic disease research for over 15 years, including basic science and clinical research in academic, biotechnology, and drug development settings. Dr. Freeman's current research interests are in mitigating disease process through dietary approaches focused on the health-promoting properties and constituents of foods. Specific disease targets are vascular, metabolic syndrome, and obesity, with special emphasis on diet, gut, brain interactions to regulate food intake. In her current appointment at IFSH IIT, she leads a nutrition and health initiative with food industry partners and government collaborators to develop and provide scientific underpinnings that will support comprehensive approaches to innovative ways to improve health and quality of life for Americans through diet and lifestyle choices. So Dr. Burton Freeman, we welcome you to the podium.
Okay, well, good afternoon. I want to thank the organizers for inviting me for this event. I think it's an incredibly important topic, and certainly Arlene set the stage for the importance with some remarkable statistics. With those statistics, I think that you would agree that obesity is the most, or at least one of the most significant nutritional health problems facing our nation and the world today. Obesity knows no strangers. As Arlene mentioned, adults, children, males, females, people across cultures and across ethnicities and socioeconomic regions are afflicted by obesity. Obesity increases the risk of a number of chronic diseases. Just looking at this graphic on the right, as BMI increases, as your category of BMI increases, there's a profound increase in hypertension, type 2 diabetes, osteoarthritis. There's an increase in some cancers. There's a direct link, and towards the end I'll talk about maybe what one of the main components of that link might be. Accordingly, obesity contributes to premature death, reduced quality of life, extensive medical costs, and loss of productivity. So why are we overweight? And why do we continue to gain weight? I suppose if we had the answer to those questions, we wouldn't be here. And as Arlene mentioned, it's a complex problem. Body weight is a result of genes, metabolism, behavior, environment, culture, and socioeconomic status. If we look at this list and how these factors interact, two that we can pull out are behavior and environment. And those have been the targets of regulatory agencies and policymakers, is how can we change behavior of Americans? What can we do? What can we do so that we can have a better impact on the obesity epidemic? So when we think about environment and we think about diet and lifestyle, there's a number of studies out there that look at the relationship between the intake of some of these things, so I've just thrown a few hot topics up there, and the obesity rise over the last several decades. So high fructose corn syrup is on the list, excessive soda pop consumption, dietary fat, refined carbohydrates, snacking, excessive TV time, and sleep, not enough sleep. And so our next speaker is actually going to talk quite a bit about sleep. But what counts at the end of the day are the number of calories we take in. And so we have a complex problem, obesity, but now I'm going to look at it from a more simplistic standpoint and bring some of you back to maybe your basic days of biology or a basic nutrition class where you looked at the energy balance equation. To achieve energy balance, it's a basic equation of balancing energy intake with energy expenditure. And when there's an imbalance in intake and expenditure, you have changes in body weight either up or down. And so obesity, weight gain, is associated or caused by too many calories in and too many or too few out. So over the decades where obesity has increased, we could look at these two factors, the energy intake or the energy expenditure, and see how they've changed over the years to see if it describes what would be the cause of obesity. And so there's been a number of people that have looked at energy expenditure, and I thought that it'd be useful to take a look at that because I think there has been some dramatic changes in energy expenditure. If you look at the data, though, and several people have published on this, energy expenditure has been relatively stable, and the changes that have occurred prior to the 80s, and that's where Arlene showed you where obesity really started taking off. So if you look at energy intake, so this is the other part of the equation, what does the data look like? Well, as shown by this is per capita consumption. These are estimated energy intakes from the 70s and 2000s. You can see that in children, as well as adults, there's been an increase in energy intake. If you ask the question, where is that energy or that excess intake coming in? Here we have on the top panel males and on the bottom panel females. These are the totals from the 70s versus the 90s for both males and now females. These are meals versus snacks, and I've highlighted the snacks because if you look at the difference in total intake in this 20-year period, most of it's accounted for by the change in snack intake. So that brings us to snacking and people's views on snacking. There's a controversy, and two very opposing opinions has to do with, one, that we should absolutely avoid it and there should be policies and some sort of guidance for people to avoid snacking. Snack foods are, is it gone? Oh, it's gone from my screen, apologies. Snack foods, I'm going to step away here so I can see what I'm talking about, are energy dense, nutrient poor. They generally have a very low satiating capacity. Therefore, they promote passive overconsumption and therefore weight gain. If we take a different approach and think about snacking as if it's not ever going to go away, and I would submit that if we think about modern lifestyle, it probably is not going to go away. We're an on-the-go society, and we have become creatures of habit to some degree. We like to grab food and go. If you look at moms and kids are always snacking on something, and so it's a behavior that's become ingrained. So could we look at snacking in a little bit different light and potentially as an opportunity to improve quality of the diet? Way to diversify nutrient intake, maybe provide a means for appetite control and weight management, or perhaps have an influence on other physiological factors. And so this is a little bit different in thinking because I think most would say, well, snacking looks like it has a pretty good part to play in the obesity epidemic, so if we get rid of that, then we should be good to go. But from a success standpoint and considering lifestyle changes and how difficult it is to get people to change behavior, I think we'd have a much better opportunity in staying in the lifestyle and making improvements. So the working hypothesis, behavior of snacking is not detrimental, but rather the foods chosen as snacks can impact health. So I think this represents an opportunity, and why? If you look at the statistics, about 25% of the energy intake that we consume on a daily basis comes from snacks. So making improvements on that 25% could have valuable effects on at least stopping weight gain and maybe even turning the tide, reversing those trends. I think it's interesting, and I put it up here just to, for us to all think about, is that with the new USDA MyPlate icon and what that signifies, and think about what that signifies to you. Does that capture what you would eat off the plate? And so should we be thinking about off-the-plate dietary guidance that then would capture that guidance around snacking behavior? So something to think about. So coming back to our energy Balance equation, I'd like to just talk a little bit about the energy intake side of it. And some people would say, well, you just kind of eat till you're full, and that's about all there is to it. But actually, it's a very complex system. The control of food intake is extremely complex, involves the periphery as well as central systems, and has a number of redundancies. So you just can't knock out part of it or stimulate one part of it without dealing with compensation. There are a number of dietary as well as non-dietary factors. Here are some of the non-dietary factors, and I'll give you a list of some of the dietary ones. But basically what I'd like to show here is that diet has a significant role to play in short-term food intake control as well as long-term energy balance. And this schematic here looks at satiation and satiety. And I put it up there because it demonstrates that we have controls not only on a meal-to-meal basis, but then overall. So when we think about approaching a meal, we have meal initiation, the maintenance of that meal, and termination. But the control of food intake at a meal is governed by the terminating factors. And the primary processes involved are satiation and satiety. And so shown on this scale is satiation, which is a within-meal event. It's what brings eating to an end. And satiety, which is a between-meal event. So this is what inhibits further eating from happening. So why don't you eat between breakfast and lunch, or lunch and dinner, or why do you? And then when you do approach that next meal, are you ravenous? And there's a whole biology that goes along with that. We have a number of sensory mechanisms, chemical, mechanical, and we have stimulation of factors from the gastrointestinal tract. So we have pre-absorptive as well as post-absorptive signals that then signal to the brain that are integrated that give us a sense for how we should approach food intake. And so I just put up this general anatomical sketch of peripheral signals that are arising from the GI tract as well as the adipose tissue, their convergence in the brain, and then their interaction. So we have our short-term signals, our long-term signals, and then we have the integration at the brain. So Arlene talked about leptin. So leptin is one of those long-term signals. It signals the brain about the energy status of the system, so the energy status of your body. If you got a lot of fat on board, you got a lot of energy stored away. And so leptin increases. Short-term signals don't work that way. They work on a meal-to-meal basis. And I put a few up here for you to take a look at, because what I think is remarkable here is that if you look on the left-hand side of the screen, you have a whole list, and this is just top 20 that I put up there. There's many more. And they're associated with decreasing food intake, so inhibiting food intake. So your body actually has a lot of systems to knock down food intake when you're done. Whether we listen to them or not is another story. From the periphery, though, there's only one signal. This is a peptide called ghrelin that increases appetite. And so in a food intake situation, in the fasting state, ghrelin's going to be high to signal that it's time to eat, and after you eat, it'll be suppressed. And conversely, the other peptides will be low in the fasting state, and they'll increase after you eat. So the dietary factors that influence satiation, satiety are shown here. So energy is a big one. Volume, food form, another important component, macronutrient composition, the availability of nutrients. And I've actually spent quite a bit of time looking at macronutrient composition and the availability of those components of the diet to stimulate various receptors in the gastrointestinal tract that can feed back to the brain and alter subjective and perceptive feelings of hunger, and then how that alters eating behavior. So if we just take macronutrient composition for a second, and we ask the question about the optimal composition to control appetite and to manage body weight. And here are the fat, the protein, the carbohydrate, the main energy components of the diet. And then some of the ones that don't provide so much energy, but fiber, how might that interact? Or how about some non-caloric sweeteners, how might they? And if you asked, what's the optimal combination or composition, the answer that you might get from one person would be very different from another. And I think the path that we've taken for probably a bit too long is that there's a one-size-fits-all. And anybody that works in the field knows that what might work for one person for controlling their hunger or helping them to lose weight could be quite a bit different than what would be successful for another person. And so it's unlikely that there's one optimal composition, but more so multiple compositions that can be effective. So, what combination is best for you? From a public health standpoint, we can't address the best composition for each individual. Although nutrigenomics is right around the corner, perhaps we can take a blood sample, genotype, and here's your perfect diet. But we're not there yet, and I think we're quite a long way away. If we think about some basic characteristics of people, that might be a better way to go. And we've spent quite a bit of time looking at the differences between men and women. And one would suspect that men are different than women, and they are also when it comes to food intake control. So I think I have a man on the left-hand side here, yep, and a woman on the right-hand side. And what we have found is that men tend to respond more to gastric cues, more to the bulking sensations, whereas women are quite responsive to the chemical cues and intestinal phase responses. We look at responses coming from the mouth or the oral cavities, those are called cephalic phase responses. We have gastric phase, so filling of the stomach, and the intestinal phase. And so women tend to be more responsive to intestinal phase cues. Another basic characteristic in thinking about how one can control appetite and what you might respond to is, what is your starting body weight? So if you're already lean or maintain a healthy body weight, you may respond very differently to food or a meal or a snack than somebody who is overweight or obese, and whether they're at a stable weight or if they're actually on the climb up. So this is a study that we recently completed, so this is unpublished data. And what we did was we took 20 women, half of them were obese, overweight obese, a BMI of about 32, and the other half were relatively healthy weight with a BMI of 22. And we gave them a drink. It was predominantly protein, and protein is touted as one of the most satiating or the most satiating macronutrient. And we looked at their gut peptide responses and also their subjective responses around desire to eat and hunger and fullness and things like that. And I think what you'll see from this is that there's quite a marked difference in the responses over a 6-hour period of the two groups of women, normal weight and obese. And this is on that measure of ghrelin. So ghrelin was the one that I pointed out was the single peptide that increases appetite. And so what you'll see is that on the left here, the green being our overweight group and the blue being the normal or healthy weight group, there's a difference in their starting point, and that's well published. But look at what happens over 6 hours after this protein drink. You have a marked suppression, a robust suppression of ghrelin in your healthy weight women, and not so much in your overweight women. So here you might be giving something that you think is helping manage someone's appetite so they don't go on to eat more, and in fact they're not getting the response that you're expecting. If we look at one of those meal-terminating peptides, this is cholecystokinin. We actually did a number of different measures, so I'm just showing you a couple for this afternoon. This is cholecystokinin. You see the same response, but it's with the opposite effect in that it increases more robustly for cholecystokinin in the healthy weight or normal weight women, and it's blunted in the overweight, obese women. How does that look related to satiation and satiety? So we asked people about their levels of hunger and fullness and desire to eat, and I pulled just a little bit of that data. And on the top panel, we're looking at over the 6-hour period, we're looking at desire to eat. How strong is your desire to eat? It's much more suppressed in the women that are of healthy weight than those of the overweight. So that's the blue versus the red. And in both cases, hunger, desire to eat is suppressed more robustly than you see in the overweight. So is there a challenge in the signaling that's happening with these obese women? So I take you back here. On the left-hand side, we have the healthy weight individuals. On the right hand, we have the overweight or obese. And the signaling is going to the brain is not as strong, or it's weaker on the obese side. And so therefore, what's going to be the signal? It's going to be a decrease in satiety and have a potential impact of not reducing food intake, maybe not increasing it, but it would not be reducing it potentially to the level that it needs to be reduced. So if we think about our take-home message here, we have an obese phenotype that's associated with inadequate satiety signaling after a meal to regulate food intake. So we're presenting, or we've presented now, a system or a cycle that maybe one cannot get out of. And so thinking about the approaches, and if we take snacking for a minute, effective solutions may need to consider the biology behind the behavior. It's more than just behavior. We have an intense biology that when we try to reduce food intake, your body pushes back against that. And so how can we get around that? How can we help the body feel less hungry, because hunger will trump, and so that people can meet their weight loss or weight management goals? Okay, I'm going to switch gears for about 3 or 4 slides here, but you'll see how it comes together, I hope. Another topic that has really been quite hot for at least a decade or more is this idea of inflammation. Inflammation is common to a number of diseases, many that I'm showing up here on this slide. And you'll notice that it's of many of the same diseases where obesity is a major risk factor. And so if we take a closer look at obesity, and many of you may already know this, obesity is a pro-inflammatory state. It's a pro-oxidative, pro-inflammatory state. And so when we think about what we can do to mitigate that inflammation, maybe we would have a better chance at changing weight outcomes. In addition to obesity, we have the modern Western diet that also promotes inflammation on an acute standpoint. And so if we put this all together in one common diagram, we have the diet that's increasing lipids in the blood, we have this hypertriglyceridemic, hyperglycemic response, increasing oxidative stress and inflammation, feeding down a number of unfavorable pathways related to insulin resistance, endothelial dysfunction. There's a thrombosis or thrombotic component here, metabolic syndrome. But if you look at the circle here, this insulin resistance and leptin resistance that also happens impacts satiety. And again, here's that cycle. And it's being fed through inflammation. So inflammation in the periphery, inflammation in the brain, causing the issues, and it just keeps feeding back. If you put on top of that, and what comes first, we don't know, the obesity component, and particularly those people with the central obesity, it just exacerbates the problem. So what we're looking at in our lab are the new dietary strategies. What are some new things that we can do? Or maybe they're old things, but how can we perhaps utilize foods or spices or herbs or different things to help alter this oxidative and inflammatory status so that we can perhaps stop the vicious cycle and actually increase satiety and have a chance of decreasing food intake, which then may make an impact on weight change. And it would certainly have a huge impact on all these other diseases and conditions, phenotypes. So with that, I'd like to just summarize. Diet and food intake, behavior play a significant role in obesity. Snacking remains an unaddressed issue and presents an opportunity for improving dietary quality. And when we're looking at effective solutions, I think we need to consider this biobehavioral link along with the environmental and the social factors. So I'd just like to acknowledge a fair amount of people that I work with on a daily basis here at the Illinois Institute of Technology, but also collaborators and colleagues at the University of California, Davis. So thank you very much.
Okay, our next speaker will be Dr. Knudsen. Her background is in biomedical anthropology, and she has been part of the sleep research and neuroendocrinology research laboratory at the University of Chicago since 2001. She is currently an assistant professor in the section of pulmonary and critical care medicine in the Department of Medicine. Her research focuses on the association between sleep and cardiometabolic disease risk, such as hypertension, diabetes, and obesity in various populations. She is also interested in identifying physiologic and/or social factors that might predict impaired or insufficient sleep. So thank you very much, Dr. Knudsen, for taking the podium.
So high tech in here. So today what I would like to review for you is the association between sleep and obesity risk. In particular, I'm going to focus on short sleep duration. In fact, it looks like there has been an increase in the proportion of short sleepers in the United States over the past 15 to 20 years. This figure presents the percentage of adults who report sleeping 6 hours or less per night for men on the left and women on the right over different age groups. The light blue bar is the proportion of short sleepers in 1985, and the darker blue bar is the proportion in 2004. And what you can see is that the proportion has increased for both men and women at all age groups. This change in sleep duration has occurred over the same period of time that the prevalence in obesity has increased. So this figure now presents in green the average self-reported sleep duration from a variety of studies conducted between 1960 and 2000. And then the orange line is the prevalence of obesity that actually Arlene already presented earlier between 1960 and 2000, during which you saw a rapid increase in the early 1980s. And it is interesting that these two trends mirror. Of course, it doesn't demonstrate causality in either direction. But today I'm going to discuss the sleep-obesity association, and most of my talk will focus on the pathway leading from insufficient sleep to obesity risk. But of course, the arrows can go both directions, and obesity itself is associated with impaired or insufficient sleep, and I'll talk a little bit about that at the end of my presentation. So first, I'm going to conduct a really brief review of the epidemiologic studies on sleep and obesity. And then I will review some experimental studies of sleep restriction that give us some evidence about potential mechanisms linking short sleep to obesity risk, in particular as they relate to appetite regulation. And I want to point out, based on Arlene's presentation, that when I talk about obesity, it's predominantly defined as a body mass index over 30. So to date, I have counted over 60 different published articles in the literature that report an association between short sleep or disturbed sleep and higher body mass index or greater prevalence of obesity. Most of these studies were cross-sectional, so we cannot determine causal direction between sleep and obesity. But there are a few longitudinal studies that have looked at weight gain over time in relation to baseline sleep duration. And I'll present data from one study. There have actually been some U-shaped associations in the literature as well, which means that both self-reported short sleep duration, generally less than 6 hours, and self-reported long sleep duration, greater than 8 hours usually, is associated with obesity or higher body mass index. To date, we still don't really understand the mechanisms underlying the association between self-reported long sleep and obesity, so I'm not going to discuss that in detail. And finally, when looking at all the studies together, it appears that the associations are stronger, or the effect sizes are larger at younger ages than older ages, because these studies have been conducted in a wide range of age groups, from children, adolescents, up to the elderly. And so if this is true, it suggests that children and adolescents may be more vulnerable to the effects of sleep loss in terms of obesity risk, but that really needs more work and more research to verify that. So rather than present all of the 60-plus studies I've seen, I'm going to just present results from a meta-analysis that was conducted by Capuccio and colleagues. He analyzed several studies that looked at short sleep and obesity. These are all cross-sectional studies in both children on the left and adults on the right. And each of these black horizontal lines is a different study. But the blue diamond at the bottom represents the pooled odds ratio from the meta-analysis. So in children, the pooled odds ratio was 1.89, which means that children who were short sleepers, which was generally less than 10 hours of sleep per night, were 89% more likely to be obese than children who were not short sleepers. In adults, the odds ratio is 1.55, meaning that adults who were short sleepers, which again generally is less than 6 hours of sleep, were 55% more likely to be obese compared to adults reporting 7 to 8 hours of sleep per night. So here you can see the difference in effect sizes, where it's larger among children than adults. Again, these are cross-sectional, so we can't say which came first. Can't say anything. But there was some studies that looked at sleep duration in relation to weight gain over time, and one of them is the Nurses' Health Study. This analysis looked at 16 years of follow-up data in over 60,000 female nurses. What this figure is presenting is weight in kilograms by sleep duration category, the sleep duration they reported in 1986. So this is their weight from 1986 up till 2002. This top line are those who reported sleeping 5 hours or less in 1986. The bottom two lines that are almost identical are the 7 to 8 hour sleepers, and then the 6 hours and 9 hours are in the middle. You can see that the shortest sleepers, the 5 hours, started at a higher weight than the other groups, excuse me, but they also increased weight more rapidly over the 16 years compared to the other sleep duration groups. They also looked at the weight gain in relation to sleep duration in another way. They compared the shortest sleep duration, the 5 hours or less, to those sleeping 7 hours per night, and calculated hazard ratios for gaining 10 kilograms over 16 years, 15, 20, and 25 kilograms over 16 years. If we look at 10 kilograms, which is about 22 pounds, the risk was about between 20 and 30% greater that those reporting sleeping 5 hours or less would gain 22 pounds over 16 years compared to those reporting 7 hours. If we jump to the opposite end at 25 kilograms, so now over 50 pounds, the short sleepers were closer to 50 or 60% more likely to gain that much weight over 16 years compared to the 7 hour sleepers. And this is after adjustment for several covariates. So in general, the epidemiologic studies suggest there is an association between sleep and obesity. So now I'm going to present results from experimental studies to give us some idea of why short sleep might lead to weight gain. And I'm going to focus on two hormones involved in appetite regulation, and Britt nicely summarized them for me already, but it's leptin and ghrelin. So again, leptin, which is secreted by the adipocytes or the fat cells, is a satiety signal over a longer term and would act as more of an appetite suppressant. Ghrelin, on the other hand, is an appetite stimulant that's secreted predominantly by the stomach. And so leptin and ghrelin have opposing actions on appetite. So I'm going to discuss two different experimental studies. The first is one that involves 6 days of sleep restriction and sleep extension, which we call the sleep debt study. And then the second one involved only 2 days of sleep restriction and sleep extension, but in a randomized crossover design. So this is the protocol of the sleep debt study, and I just want to acknowledge Karine Spiegel and Ev Van Cotter, who led this work at the University of Chicago. In this study, 11 healthy, lean men spent 16 consecutive nights in the laboratory. The first 3 nights in black were baseline nights and allowed 8 hours in bed at night. The next 6 nights was the sleep restriction or sleep debt condition in orange or red, and allowed 4 hours in bed per night. And then the last 7 nights was the sleep extension or sleep recovery period that allowed 12 hours in bed per night. This dotted red line represents 24-hour blood sampling. So it began after the 6th night of sleep restriction and after the 6th night of sleep extension. And in these blood samples, leptin was measured. So this figure is going to present the 24-hour profile of the leptin levels in the study in the subjects. This first line in green is the leptin profiles after the 6 nights of sleep extension or the long sleep period. This green bar at the top represents when they were in bed. And as you can see, leptin levels increase throughout the day after each meal and then decline at night. What about after sleep debt? Leptin levels were significantly lower at all times of the day after the sleep restriction condition compared to sleep extension. If we summarize these values over the 24-hour period, we see that on average, leptin levels declined by about 20%. So this would suggest that appetite would be higher because leptin is supposed to suppress appetite after sleep restriction. But in this study, subjective measures of appetite and hunger were not assessed. Thus, the second study, which involved 2 days of sleep restriction to 4 hours per night versus 2 nights of 10 hours in bed in a randomized crossover design. During the day after the second night, subjects underwent constant glucose infusion, so no meals, and blood was sampled every 20 minutes. And this time, both leptin and ghrelin were measured on these blood samples. And then subjects were also asked to complete visual analog scales about their subjective hunger and appetite every hour. So we'll look again at leptin levels first. This green line again presents the leptin levels during the sleep extension or the long sleep condition of 2 nights of 10 hours in bed. It's a flat line this time because it is constant glucose infusion and no meals. If we compare that to 2 nights of 4 hours in bed, again, we see significant reduction in leptin levels at all times across the day, between 9 a.m. and 9 p.m. These are the ghrelin levels after the long sleep condition, or 10 hours in bed. And again, the red is after the short sleep condition, and this time ghrelin levels are significantly higher after sleep restriction. So if we summarize these values, we can see that leptin declined by about 18% after 2 nights of 4 hours in bed, which is very similar to the 20% decline in the previous study. Ghrelin increased on average by about 28% over this time period. So again, the changes in these hormones are in a direction that would suggest increased appetite or increased hunger after short sleep compared to after longer sleep periods. But again, we asked them about their subjective hunger and appetite so we could determine whether, in fact, hunger and appetite change. So here's hunger. Hunger scores based on a single question, and global appetite scores based on a combination of several questions. And for both measures, hunger and appetite increased across the day. Remember, they're not eating any meals, so their stomachs do remain empty. So it's not surprising hunger is increasing. After short sleep 2 nights, hunger was significantly higher at all time points across the day, as was appetite. If we summarize these scores, we see that appetite and hunger increased by about 23 to 24% across the compared to in the 2 conditions, after 2 nights of 4 hours in bed compared to 2 nights of 10 hours in bed. Those were global appetite scores, but the specific food appetite for specific food types were also examined separately. So again, overall appetite increased by about 23%, as indicated by this green bar. And then here are all the different food types from the questions that went into calculating global appetite. You can see readily that not all food types increased equally for appetite across the board. In fact, the appetite for sweets, cake, candy, cookies, ice cream, salty food, which include potato chips, tortilla chips, nuts, starchy food like bread, pasta, potatoes, French fries, increased more than appetite for the fruits, the vegetables, meat, and dairy. So this would suggest, if we let them eat, which we didn't, that they would be more likely to select the high carbohydrate, high fat foods or junk foods. So this figure is just summarizing again the pathways from insufficient sleep or short sleep to obesity risk. And so far I've focused on the middle of this pathway, such that short sleep would be associated with increased hypothalamic activity in terms of appetite regulation as a result of changes in leptin and ghrelin, which in turn increases appetite. And if the increased appetite led to excessive food intake relative to energy expenditure, that would increase weight gain, which could ultimately lead to obesity. Another important pathway that needs to be acknowledged is that short sleep increases the time awake and therefore the time and opportunities for you to eat. Conversely, if you're sleeping, you're not eating. So if you're sleeping less and awake more and you eat more and that excessive food intake leads to weight gain, that too could lead to obesity. The third pathway involves cortisol. I'll show you data in a minute indicating that cortisol levels are higher after sleep restriction. Cortisol is a hormone that is released by the adrenal gland in response to stress, so it is part of the stress response. And data has shown that high cortisol levels are associated with weight gain, in particular abdominal obesity. So these are the cortisol levels across a 24-hour period from the sleep debt study, the study I previously showed you with 6 days of sleep restriction compared to 6 days of sleep extension. The sleep restriction, again, is in red on the left, and the sleep extension is in green on the right. The shaded box are the cortisol levels between 4 p.m. and 9 p.m. And you can see that this box is bigger than this box, and this is a significant difference, indicating higher levels of cortisol in the evening after short sleep compared to long sleep. This horizontal blue bar is the quiescent period of cortisol, which simply means the period of time when cortisol levels are low. And this period, this quiescent period, is shorter after short sleep than after long sleep. So taken together, these profiles of cortisol indicate an extended exposure to higher cortisol levels across the day. So again, I've been focusing mostly on the pathway leading from insufficient sleep to obesity risk, but it goes both ways. Obesity is also associated with insufficient or impaired sleep, most commonly in relation to the prevalence or risk of obstructive sleep apnea. So obstructive sleep apnea is a sleep disorder characterized by difficulties breathing during sleep. It's defined by an apnea-hypopnea index. Apnea is a cessation of breathing, and a hypopnea is a reduction in breathing. So it's the number of apneas plus hypopneas per hour of sleep. And a cutoff of 15 is commonly used to identify moderate sleep apnea or higher sleep apnea. So if you look by BMI category to normal weight, overweight, beginning of obese, and morbid obesity, you can see that for both men who are in blue and women in green, the prevalence of obstructive sleep apnea increases with increasing BMI. This figure from this paper breaks down how many of the cases, what proportion of the cases of obstructive sleep apnea are attributable to being overweight or obese. So we have men are the two bars on the left. Men have obstructive sleep, are at greater risk of obstructive sleep apnea than women. And so the women are on the right, two different age groups, 30 to 49 or 50 to 69. And regardless of whether it's men or women or which age it is, at least 50% of the cases of obstructive sleep apnea are attributable to being overweight or obese. You may wonder, who cares? Well, obstructive sleep apnea has important health consequences independently of their own BMI. So obstructive sleep apnea has been associated with increased risk of diabetes, stroke, and cardiovascular disease, even after you take into account their obesity level. So just to summarize the association between sleep and obesity, again, we feel insufficient sleep is associated with obesity, and I've shown some data from experimental studies that provide evidence for mechanisms linking short sleep to obesity risk, in particular as it relates to appetite regulation. But obesity itself also can impair sleep or lead to insufficient sleep through the risk of obstructive sleep apnea, a sleep disorder with important cardiometabolic health consequences. I just want to end by acknowledging the Institute of Medicine's recent report called The Leading Health Indicators for Healthy People 2020. Healthy People 2020 is the latest Healthy People initiative. Its goal is to improve the health of Americans, all Americans, over the next 10 years. The committee put together 24 different objectives in order to reach Healthy People 2020, and number 22 is increase the proportion of adults who get sufficient sleep. So it has been recognized that sufficient sleep is an important health behavior. And today I've sort of reviewed the evidence that it may be particularly important for understanding obesity risk. Thank you.
Well, that was fantastic. Thank you again to all of our speakers. And now we would like to open up to the audience. Any questions or comments you may wish to share with us? We had a lot of stimulating conversation. I wonder if I might start with the first question and just ask what your thoughts are about some of these interesting diets that are out there, such as the Atkins diet. versus maybe some of the more traditional diets. Do you have some thoughts about that?
Guess that's for me. Well, there's quite a bit of data that says that the tried and true slower loss of weight is the best route to go. And it does take hard work and perseverance, but that's really what pays off in the long run. The Atkins diet, among a number of other fad diets, we'll call them, can be quite, or lead to quite a successful weight loss, but it doesn't keep weight off the long term. And that's usually the problem. We're really good at losing weight for a short period of time, but maintaining weight loss is where we have difficulty.
A question.
I have a question about the sleep. I'm just wondering if there are any studies that have looked at whether people have experienced changes in weight gain if they've been treated for their sleep. So we can extend people.
Can you repeat the question?
Yes, to repeat the question and make sure I understand it, is whether the opposite studies have been done where does extending sleep help with weight control or weight loss? Excellent question. No, is the short answer. So we have shown that if we mess up with people's sleep, we can mess them up. But we haven't gone the opposite. Like if we improve sleep, can good things happen? There are studies now ongoing that are starting to look at this. The only study I can think of that is unpublished from our group that started to look at this, looked at people with type 2 diabetes, recently diagnosed with type 2 diabetes, and tried to extend their sleep. And in those who could sleep more, there was an improvement in some of their glucose measures. But you're right, there's a lot more that needs to be done, because just because if short sleep may have these deleterious outcomes, we can't say for certain that the opposite is true, that if we extend sleep in people trying to lose weight, that it will help them lose weight. We don't know that yet.
Mostly with respect to the biological effect, but also perhaps with regard to the sleep effects. The question is, to what extent can you use animal models to apply and learn, gain insight to human aspects of this question?
The question is from a biological and then also from the sleep standpoint of how much can you use or what is the relevance of animal models in understanding those pathways. And I'll tell you, I started out my life in food intake regulation using rodent models. And during my postdoc, what I wanted to determine was whether what I was showing in that rodent model was applicable to humans. And absolutely it was. And so from the work that I've been doing and others in my field, rodent models are fantastic models. And particularly when you start thinking about mechanisms in the brain and the relationship between the gut and the brain. So it's almost absolute to understand what's going on. I'll add to that, certainly being able to utilize humans is an important part of it, because as brought up with the leptin story, you know, leptin worked great as anti-obesity agents in rodents. But when you look at leptin as an anti-obesity agent in humans, it doesn't work. Okay, so, and that's because we do have those differences between animals and humans. So at some point, you got to get to the human model. I think imaging technology will help us get into the brain. And I'm actually really excited about that technology. And as it gets more and more specific to being able to do tracings and being able to pull the peripheral and central mechanisms together. But yeah, absolutely.
And then with respect to animal models in sleep, is this on? Oh, sorry. They certainly exist, and there have been many animal models of sleep deprivation, because we can do to animals but we can't ethically do to people, such as keep them awake indefinitely. And for the record, rats die after 2 weeks of being kept awake, and so we can't do that to people. But with respect to weight loss, in the total sleep deprivation with animals, they actually lose weight. But there's so many things going on there, and they end up dying, that we don't really understand what that is. And with the issue with rodent models is they're nocturnal and we're not. And they also have brown adipose tissue, which gets involved. And so it makes it a little tricky to apply to humans, but there certainly are animal models out there.
One of the speakers talked about the inflammation risks. And looking at the packaged food labels, we know how to read the calories and stuff, but what are the readings on those labels that would give us a hint about inflammation?
So the question is about inflammation and labels that tell us about calories and fat and carbohydrate content, but they don't tell us about whether they would have an impact on things like inflammation. Is that right? And so how could you look at a food and determine whether it would have some anti-inflammatory qualities? Right now, we don't have labels that would tell you that. There's quite a bit of research that's going on looking at phytonutrients, so polyphenols that are in wine, for example, in berries, in various spices that have these anti-inflammatory effects. And so where you're probably going to hear about that is when you're looking at functional foods. That's usually what it falls under. And so right now there's not a way to look at a food per se and determine whether it has anti-inflammatory effects other than knowing classes of foods. So if you're looking at berries, there's a fair amount of research now that's collecting on berries having anti-inflammatory effects. Various herbs and spices, again, having some of these anti-inflammatory effects. However, if you look at lipids, it's fairly well known that fish oil has an anti-inflammatory effect. And so it's not that you would look at the oil, you would just more or less these days have to know.
Way in the back.
Okay, so I have two questions. My first question is related to the BMI predictor. Is that a really good predictor for obesity in children? And then my second question is, why wasn't sugar included on your list as opposed to high fructose corn syrup? What's the difference between that and the breakdown? Is that related to obesity?
Okay, so I'll address the question about whether or not BMI is a good predictor of overweight and obesity in children. So let me say first that BMI is only an estimate of the percent body fat that we have. And BMI as a tool is really good to look at obesity in a population. But in an individual, it varies in the accuracy that it may have to represent your actual percent body fat. In children, because we expect children to grow both to gain weight and to gain length, we use a percentile where we compare kids against a larger group of children who are of the same age and sex, so that we can so we can better provide an estimate of their percent body fat. But BMI is limited. It's definitely limited in kids because we expect kids to grow, but as it stands, it is a pretty good estimate in kids to represent someone who is obese, someone who is greater than in the 95th percentile for their age and gender is going to have a larger percentage body fat. And you can hold that to be pretty true. And the problem with that in kids is that half of kids who are obese become obese adults. And so it's the tracking of obesity from childhood to adulthood that is really the problem. So BMI works in kids.
Yeah, the question about sugar versus high fructose corn syrup. I was just putting a list on the slide of sort of the hot topics that people are investigating in the relationship to obesity. Sugar could go up there just as easily. And high fructose corn syrup is a hot button for a lot of people. The difference between high fructose corn syrup and table sugar is minimal. So if you look at the ratio of glucose to fructose and table sugar, it's 50-50. And for high fructose corn syrup that you find in your soda pops, it's a ratio of 45 to 55. So there's really not that big a difference. The take-home message is that we're eating far too much of any of it. Sugar, high fructose corn syrup, everything. So it just all, as a whole, needs to come down.
There are multiple. I've been in the food industry for 40 years, and all the research that I've been reading over a 40-year time period, I think while the science is interesting, but when I look at each of the things with your charts, I can tell you what happened in the food industry at each of those time periods. You're starting with the first person who spoke. You're 1980 to 88, 88 to 94. Women entered the workforce, more highly processed convenient foods, food away from home increased to food away from home. I love my industry, but if you don't start studying that food industry to change what is going on, all the research in the world isn't going to change this obesity problem. So one is, I think, looking at what's happening in our society directly impacts is why you saw that amazing increase and why it continues. And it won't stop until you start researching and studying how to change what's happening in the food industry with that. Second, with the signals, you didn't look at food marketing. You know, the signals that I will tell you that I look at all the time is my industry that spends multi-billions of dollars every single year targeting and marketing from young adults, highly processed, highly, non-nutritional foods. And if you look at, it's not just the signals in marketing, if you look at every dietary pattern, look at where the food is, the first purchase in a supermarket as you start walking your way and winding you around, what is put at the entrance of it. If you look at the smells, and in every place that we have smells going from the movie theaters today to the bookstores to all of the non-traditional places, if you would look and study and start focusing on that, I think you'd find it. And over the sleeping hours, if you looked at what people are doing in the non-sleeping hours and how much stimulation they are also seeing about food. And here's one more for you to take a look at. We now have mobile apps so that people don't even have to leave their chair today in a concession place to have food delivered to them in a sports theater, stadium, or at a concert, or food delivery 24 plus today. If you would look and really hone in on what has changed in the dynamics of the food and the accessibility and the non-traditional, and then take it maybe to the science, maybe we could start changing behavior and reducing the increased obesity would be something I would put out there for you to take a look at.
Just a quick comment related to that is, I'm surprised you didn't mention it with respect especially to sleep, is caffeine, like with Starbucks and then all these right. Caffeinated, what do they call, energy drinks that are targeted towards adolescents. I mean, it's a nightmare.
So I think just to comment on that, you're absolutely right. We've created what they call an obesogenic environment. And unfortunately, a lot of people like it. They like the conveniences that are out there. They like that tasty food. They like all the things that you're talking about. And so the biggest hurdle is the behavior change. And we haven't done a really good job of that. So it's a great point.
Any correlation, positive, negative, or maybe none whatsoever, between smoking and obesity?
So in general, smoking decreases BMI for a couple of reasons. First, because it nicotine has a direct effect on eating behaviors, and in terms of nicotine being an appetite suppressant. So when people stop smoking, what you can expect is to gain, on average, 2 to 7 pounds. Now that's on average, and many people's experience is different, but there is what I like to say, an inverse association between cigarette smoking and BMI. Smoking is not protective in any way, so I would never say that smoking has no benefit in terms of health at all. So I will never put it in those terms, but smoking is inversely related to BMI for those two reasons.
Excuse me. Thank you, all three of you, for just excellent talks and informative. I learned so much. Dr. Hankinson, The graph you showed about socioeconomic status and trying to relate proximity to unhealthy and healthy food. Has anyone tried to do that with breastfeeding versus formula feeding? Because I think there could be some treasure there relative to the protective effect of breastfeeding that's getting a lot of attention now, and the deleterious effects on obesity. You know, infant formula is a sugar-sweetened beverage. I don't know if everyone knows that, but that's pretty much coming out in the wash here. And I just wonder, do you have any comments about that?
To repeat, is there any data relating breastfeeding versus formula feeding to BMI? And as far as I know, no, but that's as far as I know, and so I need to go back because that's an excellent question.
I would just point out to maybe that question is that 1950 and 1960, when I was growing up, the moms did breastfeed, and we were the healthiest, had the least allergies, the least everything. But our food supply system was the healthiest. We didn't have the hormones being added to the antibiotics or the hormones being added to increase the growth rate of animals, so dairy, milk, all of those. We didn't have the GMOs, which nobody seems to know how that is really impacting us through all the grains. So I think, again, you have to look at, I'm not sure it's the breastfeeding versus non because of that time period when they didn't breastfeed, but I will tell you that even if you're breastfeeding, you better look at the food supply source that the mother's even consuming that's high in hormones and antibiotics and all those other things, because those are changing the dynamics of the, I think, children today and how they are growing up healthy.
My question was socioeconomic status in breastfeeding, not protective effect of breast. That's unequivocal. Breast milk is protective against obesity, but I don't know of any data that exists. Do lower socioeconomic status mothers, were they breastfed, do they breastfeed versus formula?
Right, yeah, I don't know, yeah.
I don't know much about this, but I have a colleague at University of Michigan, or at Michigan State rather, that works in that field. And in talking to her, friend to friend, and hearing about what she's doing, there's actually a high rate of non-breastfeeding moms that are in the low-income setting, and that's where she focuses her research. I can't give you numbers, but that's what she's telling me.
How about her email? Can you give me her?
You betcha, I can.
This event starts with the science of obesity, and the next session has to do with the policy. It's an area in which I don't have expertise, and I very much appreciate learning and hearing what you folks have to say. But as a citizen, and as an informed citizen, I don't trust the government, whatever level that government is. And I wish to have information that I can come to some conclusions myself. In this area, it's so complex, so multidimensional. Much of what you've said is hard to sort of put into a context where I can be the judge. But in anticipation of, I don't know what we're going to hear in the next session, my general question is, does science, from your perspective, closely correlate with the direction that public policy seems to be taking, whether it's the local level or more broadly, or are the pressures from our economics, from our culture, from our society such that they overwhelm the science? And this is from an informed citizen point of view. I'd like your advice or guidance.
All right. Well, I think we should all three take a stab, and I'll take the first stab. Your question about how to make an informed decision as it relates to the science, and what impact science has on policy. Where do we see the future policy decisions as it relates to science? And I'll briefly go back in history to just say, even at the point when the first consensus panel was held at the NIH about obesity, there was a lot of scientific turmoil that resulted in, that wasn't seen in the policy. So the policy sort of reflects something that isn't reflected in the science. The science is so complex that it's difficult to develop a uniform policy or develop, a comprehensive policy that really can account for all of what we don't know. So what I would say the direction is that we would continue to have policies that really are surface and that don't address the complexities at the individual level, don't address the conflicting interests between industry and government that really determine a lot of what goes on for land use, for agricultural policies, and the gamut. So as a concerned citizen, I would make your individual decisions and understand that there are very complex community level things that go on that government, to your point, will inadequately address.
Okay. Oh, okay. So we ended on a hard question, but so I have sort of two different ways to answer it. The first is that, when you're in science, we're always acknowledging this is a very complex issue, this is very complicated, there's no easy answer. And then the politicians want a soundbite in 5 words or less, explain the issue to me and how I fix it. And those lines of communication are difficult to bridge. And so I think it'll always be a challenge to take a very complicated issue like obesity and causes and consequences and turn it into government policy when your scientists are trying to work with politicians. But also, I don't remember if Mary mentioned this, but I'm actually an anthropologist. And so when I'm particularly interested in culture and social factors as they relate to things. And for me, with relationship to sleep, if we believe that short sleep is bad for you, there's a big hurdle in this country, I feel, culturally, to get people to sleep more, because we are a country that prides itself and values productivity above all, economic and workplace productivity. And I know all of you, if you have not said this yourself, you know someone who has bragged about the fact that they only got 3, 4, 5 hours of sleep the night before. It's a sign that we are a productive member of our society. And when I say I spend 8 to 9 hours in bed, people just shake their head in disbelief and are like, really? And I get more done during the day because I'm well rested, but it's this big hurdle to get over, to explain to people.
Well, I'm not sure if I can add much other than I think that it's one thing that I've seen, and I do have an opportunity to work a little bit more closely with the government, is that it's extremely slow, is what I see. There's been science around about obesity for a long time, and the translation of that to how it can be utilized in a public health, public policy setting is just not happening very quickly, and I don't understand if that's because we don't know how. There's a lack of resources, which I think is really a part of that. I think we do know how. It's just there's resource constraints. There's the politics. Politics present a constraint, whether we like that or not. So I don't necessarily see policy pushing back to change the science, but I do see the translation from science to policy is very slow, and because of the political piece, yeah, I'll just say that.
Thank you so much. Well, I'd like to thank our speakers again and all of your great questions, our audience, and I'd like to invite you for a short break before we start our second day. Thank you.